Okay, here in example 5, we have a triangle. A is 12, B is 31, angle A is 20.5 degrees. So the first thing I'm doing is just drawing a triangle. I'm going to label it. Angle A 20.5 degrees, side A 12 meters, side B 31 meters. Upon inspection, it appears I have side non-included angles, so that's SSA. And since it's SSA, I know typically going to be 0, 1, or 2 solutions. Therefore, the first thing I have to do is compare A to B. And since I have side A is less than B, that means it's either 0 or 2 solutions, so cross out the possibility of 1. Now I have to find the H, as we have done on the last two things. And H, if you recall, is B sine A. So that's going to be 31 times the sine of 20.5 degrees. 31 times the sine of 20.5 degrees is 10.86. Okay, 10.86. And we said if H was less than A, then there were 2 solutions. And if H is greater than A, then there's no solutions. Well, in this situation, the H is less than A, so this is a 2 solution triangle. What that means is there are 2 distinct triangles that can have these measurements, and our job is to find both of them. So the first thing I'm going to do is I'm going to make myself a little list here, and this is triangle 1, and I'm going to call it triangle 2. This triangle, the triangle symbol in 1, triangle symbol in 2. That way I know I can have 2 possible triangles here. So for triangle 1, the first thing I have to do is the first thing I can do is solve for angle B. And so it's 12 over the sine of 20.5 degrees equals 31 over the sine of angle B. I'll do 31 times sine 20.5 degrees, divide that by 12, and it'll be the sine of B equal to 0.9047. Now I'm going to take arc sine of B in the calculator, and B turns out to be 64.8 degrees in triangle 1. Okay? Sticking with triangle 1, I now can find angle C, because angle C has to be 180 minus 20.5 minus 64.8. So 180 minus 20, and all that's going to give me 94.7 degrees. So C1 is going to be 94.7 degrees. And I should call this B1 because we're talking about triangle 1, so I label it C1 and B1 just so I can keep myself clear and straight. The only thing I need now is side C, and so I can go again with 12 over the sine of 20.5 degrees equals side C over the sine of 94.7 degrees. Excuse me. So I take 12 times sine 94.7 degrees, divide by the sine of 20.5 degrees, and I get the C1 to be 34.15 meters. And now I've solved the rest of this triangle. I'm given 2 sides and an angle. I've found the 2 angles in the third side, so now I've solved it for one of the possibilities. For the other possibility, this is what I have to do. I have to take 180 degrees, and I have to subtract the 64.8 I got in the first problem. So minus 64.8 degrees. And so 180 minus 64.8 degrees turns out to be 115.2 degrees. So that means B sub 2, or the other possibility for angle B, is 115.2 degrees. Let's talk again how I did that. I found B1, the first possibility for B, by using law of sines, as you see here. And then for triangle 2, the other possibility is that this angle and the rest of the two angles would add up to 180, and so I'd get 115.2 degrees for the other possible triangle. That means for C2, angle C2, it's going to be 180 minus 115.2 minus 20.5. So C2 turns out to be 44.3 degrees, 44.3 degrees. To find side C2, I go back to what the original information, which is 12 over the sine of 20.5 degrees. And then I'm going to go equal to side C over the sine of 44.3 degrees. And I do 12 times the sine of 44.3 degrees. Divide that by the sine of 20.5 degrees. And I get the C2 equal to 23.93 meters. And that's how you find both possibilities. And yes, if you have a problem that has two possibilities, you have to find them both. Go ahead and try number 29, and it'll be the solution on the next video.